Helium and nitrogen are two of the most abundant gases on Earth, but they're also two of the most difficult to get your hands on. In this video, we'll take a look at where these gases come from and why it can be so hard to get them. Let's start with helium. This is one of the lightest elements on the periodic table, only slightly heavier than hydrogen because of its low atomic weight. It's no surprise that it's the second most abundant element in the universe. However, it's not nearly as abundant as hydrogen. There's about 13 times more hydrogen than helium out there. On Earth, though, the story is very different. While helium is still lighter than hydrogen, it's nowhere near as common. In fact, it's actually less abundant than mercury, which is a metal. So where does all the helium go? Well, it turns out that the vast majority of it is actually trapped inside of natural gas deposits deep underground. But that doesn't explain why. Why would helium be found inside of natural gas? To answer that question, let's go back to the beginning. Stars like our sun are gigantic balls of plasma held together by their own gravity. For most of their lives, they exist in a state of hydrostatic equilibrium, which just means that the force of gravity is balanced by the pressure created by the nuclear fusion in their cores. As a result, stars don't collapse in on themselves, but they also don't explode. However, all good things must come to an end, and when our sun runs out of hydrogen fuel, it will no longer be able to produce the energy needed to support itself against gravitational collapse. At that point, it will literally begin to fall in on itself, causing the outer layers to be thrown off into space. This is what's known as a red giant. As our sun enters this phase of its life, it will expand far beyond its current size, engulfing the inner solar system. Mercury, Venus, and even the Earth will be vaporized and added to the stellar wind blowing from the sun. All this material won't stay in the immediate vicinity for long, though. Over billions of years, it will spread throughout the galaxy, eventually becoming part of a molecular cloud. These clouds are made up of mostly hydrogen and helium, which has been blown off of other dying stars. Eventually, enough of this material will come together under the force of gravity to form new stars and planets. And because the material is already in a liquefied state, it'll have much lower boiling points than the hydrogen and helium that we're used to. In other words, the helium that we find trapped inside of natural gas deposits today was once part of the sun. But what about nitrogen? Unlike helium, it's actually very abundant on Earth, making up about 80% of our atmosphere. However, it wasn't always this way. Early Earth had very little nitrogen, and the atmosphere was mostly made up of carbon dioxide. Luckily for us, the evolution of life on Earth would eventually change all of that. You see, early organisms used compounds containing nitrogen to store and transmit genetic information. The abundance of nitrogen in our DNA is so great, in fact, that if you were to spread it out evenly across the planet, we would have a 12-foot deep layer of nitrogen covering the entire surface of the Earth. As these organisms reproduced, they also released nitrogen back into the atmosphere. But it wasn't until the evolution of photosynthetic organisms that the amount of nitrogen in the atmosphere began to increase significantly. That's because the process of photosynthesis removes carbon dioxide from the atmosphere and replaces it with nitrogen. In fact, about 100 billion kilograms of nitrogen is fixed each year through this process. It wasn't until about 540 million years ago, though, when the first animals evolved, that the amount of nitrogen in the atmosphere began to approach its current levels. Since then, it's remained relatively stable. It should be noted that while nitrogen makes up 80% of the atmosphere, 99% of that is in the form of N2, meaning that only 1% of it is biologically available. Luckily for us, humans have figured out how to convert this unusable nitrogen into ammonia, which can then be used to produce fertilizers. In fact, about 50 million tons of nitrogen is fixed each year for use in agriculture. And that's where all the helium and nitrogen comes from. Now, if you've ever tried to purchase these gases, you might have noticed that they're not exactly cheap. This is because while they're incredibly abundant on Earth, they're not exactly easy to separate from their more abundant counterparts. In the case of helium, the only practical way to obtain it is through a process known as fractional distillation of natural gas. Basically, natural gas is cooled down to a very low temperature, which causes it to condense into a liquid. From there, it can be separated into all of its different components, including helium. This process is expensive, though, which is why helium is currently valued at over $1,000 per 1,000 cubic feet. For nitrogen, the process is even more complicated since it makes up 78% of the atmosphere. Several different methods have been developed to separate it from the other gases. But the cheapest and most effective is still cryogenic distillation. Essentially, the same process that is used to separate oxygen and helium from air is used to separate nitrogen as well. So there you have it. A look at where all the helium and nitrogen in the universe comes from. If you enjoyed this video, please leave a like or comment below to let me know what you think. And as always, thanks for watching.